Yes.
Okay, let me share the screen and let me know if it is visible to all of you. Yes, are you able to look into the screen, the PDF?
Yes, miss.
Okay, so let's continue with yesterday's session. We were doing electrolysis. If you look into this question here, it says that identify the product which is formed at the anode and at the cathode during electrolysis of molten potassium chloride. Can you tell me what will be the products which will be formed at the cathode and at the anode if electrolysis of molten potassium chloride is carried out? You may write your answers in the chat box as well. Yes, Zoya.
At the cathode, we will get potassium, and at the anode, we'll get the chlorine gas. Chlorine.
Chlorine. Yes, that's right. What ions do we have within the electrolyte? Which ions are present within the electrolyte?
Potassium and chlorine ions.
Yes, potassium ions and chloride ions they are present only. Okay. So what is going to happen? Potassium ions they will be attracted towards the negative cathode, right? As a result, what will be the half equation you see at the cathode? It's going to be potassium is going to gain that electron, which is incoming from the negative terminal of the battery. As a result, it produces potassium and it deposits as potassium solid. Okay. And what about chloride ions? Chloride ions, they will be attracted towards the positively charged anode and they lose their electron to produce chlorine gas. So bubbles of chlorine gas, they are or green colored gas is seen or observed. Okay. And you're going to balance out this equation. Up till here, do we have any questions, any queries from yesterday's session as well? Yes, any questions, any queries up till now?
Yes. For the example, if we write the ionic equation between potassium and chlorine, could you write that?
The complete equation?
Yeah. No, no, the ionic equation.
The complete ionic equation, yes. These are half ionic equations. For complete ionic equations, I told you yesterday, what will you do? You are going to add up both of these ionic half equations. You need to just have equal amount of electrons on both the sides. And you will cancel the electrons and then write the rest. For instance, here, if you look into this, what will be the complete ionic equation for this one? 2K plus 2 chloride ions. They produce 2K plus chlorine gas. Okay.
Yes.
When the questions ask you, it instructs you that you have to mention the complete ionic equation, then only you have to mention it. Otherwise, if they ask you half ionic equations, then you would have to do so. Okay, moving on to the electrolysis of aqueous solutions. Now, what happens in aqueous solutions? Aqueous basically refers to that the particular solute has been added to water. Hence, it produces a solution. Okay, and this solution is now an aqueous solution. So, when electrolysis of aqueous solutions are carried out, the water molecules they tend to dissociate, and when they dissociate, they produce their hydrogen ions and hydroxide ions subsequently. Okay, now, the case scenario completely changes here. The products which are formed or deposited onto the cathode and the anode completely changes. Now, this is also dependent upon like which ions will be discharged and at which electrode. Completely depends upon the reactivity of the elements, the relative reactivity of the elements. For instance, if I say for metals, look at for cations, supposedly for cation, supposingly you have hydrogen ions which are present if it's a aqueous solution of sodium chloride, supposingly. Okay, you have NaCl aqueous. This means that it has sodium ions as well, and it also has hydrogen ions as well. Okay, so what will happen? The less reactive metal, if you look into the reactivity of the elements, as you go down, hydrogen comes down in the reactivity. This, which means that hydrogen is less reactive as compared to sodium. The less reactive one has the greater tendency to be deposited onto the cathode. Okay, so since cations are attracted towards the cathode, so hydrogen will be attracted towards the cathode. It has greater tendency to be deposited onto the cathode because of its less reactivity. The more reactive element stays within the solution. Okay, so sodium stays within the solution, and hydrogen deposits onto the cathode as hydrogen gas. Okay, for anions, the concentration comes into play. Okay, now what happens when we say that you have a particular solution which is concentrated and you have another solution which is a dilute solution? So you have concentrated, sometimes the examiner they also mention concentrated aqueous sodium chloride. So don't get confused. Concentrated aqueous sodium chloride basically means that sodium chloride has been added to little amount of water. Okay, there is more amount of the solute and less amount of water. This means that sodium ions and chloride ions, they're more as compared to hydrogen ions and hydroxide ions. All right. Whereas dilute aqueous or simply dilute sodium chloride would mean that you have less amount or less concentration of the solute and more amount of the hydrogen ions and the hydroxide ions. Okay. So what happens here in this case scenario? Well, now you know that since we're talking about the anions, in concentrated chloride ions, concentrated sodium chloride, you would have chloride ions and hydroxide ions both, right? Within the solution. Yes? In concentrated aqueous sodium chloride, what do we have? We have chloride ions and hydroxide ions. Yes? So amongst these, whenever any such electrolysis takes place, the rule of thumb is that chloride ions or the halogen, whatever halogen it is, be it chloride or be it bromide, iodide, anything, it has the greatest tendency to be deposited only if it is a concentrated halide. Okay, halide refers to that it is a compound which is made of the halogen. It has halogen present in it. And what are halogens? Halogens, they are group 7 elements. So that group 7 element will be deposited. So here in this case scenario, chlorine will be deposited onto the anode, leaving behind hydroxide within the electrolyte. Okay. But in case you have supposingly dilute hydrochloric acid, supposingly, or you have dilute sodium chloride, aqueous dilute sodium chloride, this means that you have less amount of the less concentration of the solute, which means that chloride ions, they're less as compared to hydroxide ions. And hydroxide ions, they get a tendency to they get a chance to be deposited, and wherever hydroxide ions they're deposited onto the anode, they produce oxygen gas. Okay, so for dilute halides, the oxygen gas has to be produced if it's in aqueous solutions. Okay, in electrolysis of these their aqueous solutions, whereas for concentrated, the solution must be a concentrated halide for them to be deposited, for the halogen to be deposited onto the electrode, onto the anode specifically. Is this point clear so far?
Yes, miss.
Okay. Now look into another one. For instance, I say that you have dilute sulfuric acid, H2SO4. So this means that you have the anions, they are going to be sulfate and anything else other than sulfate.
Hydroxide.
Hmm. Hydroxide. Okay. Amongst these two or any other anions which are present within the electrolyte, Out of all of them, out of um, all of the halogens, all of the halide ions, all of the anions that you know, and the hydroxides. Hydroxide has the greatest tendency, it is relatively more, it has greater tendency to be deposited onto the anode. Okay. So for dilute hydrochloric acid, sulfuric acid, hydroxide ions they deposited. Hence, they produce oxygen gas, or you say that oxygen gas is evolved at the anode. What about concentrated sulfuric acid? What about concentrated sulfuric acid? What will be deposited at the anode? Yes. If I use concentrated sulfuric acid, what product is formed at the anode?
Is it sulfate?
No. This is the only rule for deposition of the anion if it's a halide. In concentrated aqueous solutions, only the halide ions are deposited for concentrated halides, okay, when their electrolysis is taking place. But for any of them, be it any other compound, always hydroxide ions they have the greater tendency to be deposited. So for concentrated sulfuric acid also, the hydroxide ions they are deposited, okay, even though sulfate ions they are present within the solution, within the electrolyte, but their tendency is not that much great. If you look into the reactivity of the anions, or their tendency to deposit onto the anode, hydroxide ion is at the bottommost, and rest of the anions they are present at the top, okay, be it the halides, be it the sulfates or nitrates or anything else. Okay, so the bottommost has the greatest tendency to be deposited onto the anode. So always remember that for any solution you have any other anion, hydroxide will get the tendency and it will deposit onto the anode, hence producing oxygen gas at the anode. But if it is a concentrated halide, then only that halogen will be deposited onto the anode. Is this point clear so far?
Yes, miss.
Okay, let's move on to the next one. So this is basically the reactivity series for the metals. The most reactive ones they are at the top. The easiest way, either you can find there are multiple mnemonics to remember this um, reactivity of the metals. Also, the easiest way out is the most reactive elements. They are usually group one. Okay, then so potassium, sodium, and lithium at the top. Then you have calcium and magnesium, which is group two. Then you have aluminum, which is group three. Okay, then comes carbon, then zinc, iron, and some of the transition elements they come in the middle. And then you have hydrogen. Below hydrogen, you have very naive metals, okay, or very least reactive. So copper, silver, gold, they lie at the bottom. Platinum also lies beneath hydrogen. Okay, so group one, two, three transition elements, and then hydrogen, and below hydrogen they are going to be the least reactive elements. Okay, so let's go through a bit of the theory part. So negatively charged hydroxide ions and non-metal ions they are attracted towards the anode. If the halide ions they are present, the halogen is produced at the anode and it loses electrons, hence forming the halogen. If there is no halide ions but hydroxide ions are present, oxygen is produced at the anode. The hydroxide ions they lose their electrons, forming oxygen gas and water. In both cases, other negative ion they always remain within the solution. And the particular rule is that if a concentrated halide solution is being electrolyzed, then halogen is going to be formed. If a dilute solution is being electrolyzed, then oxygen will be formed at the anode. So for instance, if you have concentrated barium chloride, so concentrated barium chloride is again concentrated solution of a halide, right? So chloride ions, they have a greater tendency to be deposited onto the anode as compared to hydroxide ions. All right. Moving on to um, And for the cations, the less reactive ones, they are always deposited um, onto the cathode. Look into this one. Tell me if supposingly you have hydrogen ions within the electrolyte and you have copper ions within the electrolyte. Which one will be deposited onto the cathode? Which cation will be deposited onto the cathode if both of these cations are present within the electrolyte?
Copper,
Copper. Why?
because it is less reactive than hydrogen.
Yes. So the less reactive one always is deposited onto the cathode, and the more reactive one remains within the solution. Okay. Let's look into a few examples. So aqueous solution of these substances is carried out, their electrolysis is carried out. So concentrated sodium chloride, concentrated halide it is, right? Which is why chlorine gas is produced at the anode. What about the cathode? In the cathode, hydrogen gas is produced at the cathode. Why? Because you have hydrogen ions and sodium ions, and the less reactive one is always deposited, so hydrogen gas is deposited at the cathode. In dilute sodium chloride, now since it is dilute solution of the halide, so oxygen gas is produced from hydroxide ions and hydrogen gas. The product at the cathode remains the same. Concentrated aqueous copper to sulfate. Again, concentrated word is given to you, but here, since I told you that amongst all of the anions, hydroxide ions has the greatest tendency, so oxygen gas will be deposited at the anode, and copper is deposited onto the cathode. Why? Because you have hydrogen ions and copper ions. Copper ions, they are less reactive as compared to hydrogen ions. Okay, so they are deposited onto the cathode. Dilute sulfuric acid, oxygen gas is deposited, and you only have hydrogen ions, so as the cations, so as a result hydrogen gas is only deposited. Okay, this will be the reaction for hydroxide ions. That is, four hydroxide ions, they lose 4 electrons to produce 1 mole of oxygen and 2 moles of water. Okay, let's move on to reactive metal electrodes now. Up till now, we were doing electrolysis with inert electrodes. Inert electrodes basically means the ones which are unreactive. They don't actually take part in the process of electrolysis. Okay. But reactive metal electrodes, they tend to, they play a role within the process of electrolysis. How? So for instance, if you look into this setup of electrolysis, this is a simple electrolytic setup where you have a DC current, okay, DC supply, and their connecting wires, and the anode and the cathode, and these electrodes, they are dipped within the electrolyte, which is aqueous copper 2 sulfate, and both these electrodes, they are made of copper rods. Okay, now what happens here, in this case scenario, when you have reactive metal electrodes, the copper anodes, they tend to dissolve. Okay, they form copper ions, so they lose 2 electrons and they produce copper ions. Okay, can someone tell me what ions are present within the aqueous copper 2 sulfate? What ions are present within aqueous copper 2 sulfate? Yes, Zoya.
There's copper ions,
Hmm.
there's sulfate ions, hydrogen ions, and hydroxide ions.
And hydroxide ions. Very good. So you have copper ions, you have hydroxide ions, you have hydrogen ions, and sulfate ions. Okay. Now what happens here? The reaction at the anode is that this copper anode dissolves to form copper 2 plus ions, and it loses 2 electrons. Okay, these copper 2 plus ions, they go into the electrolyte. Okay, and then they are eventually deposited onto the cathode, since they are attracted towards the copper cathode. Okay, so how what reaction takes place at the cathode? They attract two electrons, gain two electrons, and they form copper metal. So they deposit onto this cathode as copper metal, and these electrons, they are incoming towards the cathode, right? This is the electron flow. So, and what about these ions? The relative amount of production and the rate at which these copper ions are being produced and the rate at which they are being deposited onto the cathode is exactly the same. Okay. So what happens? Just a minute. Okay. So what happens when the rate of production of these copper 2 plus ions and their deposition onto the copper cathode is exactly the same? As a result, the concentration of the copper 2 plus ions, which is within the electrolyte, does not change, okay? Or relatively, it remains considerably constant, okay? And the blue color of this solution of the electrolyte that you see is actually because of the copper 2 plus ions. Tell me what is going to happen to this color. Is this color going to change if the concentration of the copper 2 plus ions within the electrolyte remains the same? Is it going to get darker blue? Is it going to remain the same? Or do you think that it will fade away or get less blue? Did you get my question?
Yes, miss.
So what do you think? The constant,
I
if the
think I think
hmm,
it will
it will,
fade
you think it will fade. Why?
because the copper will be deposited at the cathode.
But the concentration of the copper 2 plus ions within the electrolyte does not change. Don't you think that that the color of the electrolyte is basically dependent upon the concentration of the copper 2 plus ions which are present within the electrolyte?
Yes.
So if the concentration of the copper 2 plus ions is not at all changing, so the color also remains the same. Okay, the color remains the same, that is blue. Okay, neither does it darkens nor does it fade away. Okay, it remains the same. Now what happens to the mass of the copper cathode? The mass of the copper cathode increases because of greater deposition of copper onto the cathode, and the anode, since it dissolves, it loses its mass, also its mass basically decreases. All right, is this point clear so far? So we see three different observations. One is that we see that there is a decrease in mass at the copper anode, there is increase in mass at the copper cathode, and the color of the solution remains blue. Okay, it stays the same. Is this point clear so far? So the anode also gets thinner and the cathode starts to get thicker because of greater deposition of the copper, and the anode becomes thinner and thinner and thinner. And this is basically an industrial process. This is practically applicable. um, the practical application of this one is that this process is basically industrially taking place as purification of the impure copper. So to purify the impure copper, this impure copper is made the anode, and whatever copper is deposited onto the cathode becomes the basically is your pure copper, which is deposited onto the cathode. So any impurities which are present within the copper anode, they settle down beneath this copper anode and are referred to as anode sludge. Okay, Is this point clear so far?
Miss, I don't
Mhm.
understand why the mass of the anode decreases.
The anode is the anode is basically the copper rod. Okay. When this copper rod is giving away its electrons and it is losing its electrons, hence it is producing copper 2 plus ions. This means that the copper is actually converting into copper 2 plus ions, right? When it is converting into copper 2 plus ions, this copper is actually dissolving. When it is dissolving, it gets thinner. Are you getting my point? It gets
Yes.
thinner. As a result, the mass decreases. And these copper 2 plus ions, they're deposited onto the cathode, which is why the mass at the cathode tends to increase. The rate of this question is very frequently asked, why the color of the solution remains blue, and the reason is that the concentration of the copper 2 plus ions within the electrolyte remains relatively constant. And the color of any solution, if it is because of transition elements, you know that transition elements, they form colored compounds, colored complexes. So obviously the color, if the concentration of the copper 2 plus ions remains the same, then the color will also be the same. If the concentration of the copper 2 plus ions increases, the color is going to darken. If the copper 2 plus ions concentration decreases, then the color is going to fade away, or you can say that it turns pale blue, or you can say that it fades away, or you can say that it turns colorless. Are all of these points clear so far? Ayla?
Yes, Miss.
Okay. Hamdan, Ibrahim, Ahmed, Basit. All right. Let's move on to another one. So this is how the reactive metal electrodes, they basically play a role when they are used as electrodes. Okay. So in the process of electrolysis, supposingly I say, now you have the same electrolyte, but you're not using the copper cathode and the anode. You are now using carbon cathode and carbon anode. Tell me what will be the difference. Do you think will there be any difference at the for the reactions happening at the cathode and at the anode, the products which are formed? Yes. Ayla, Ahmed, Ibrahim, Basit. Yes, ji Zoya. My
Miss,
question
can you
is
repeat your
that
question?
if the electrolyte remains the same, you have same aqueous copper 2 sulfate as an electrolyte, and however, the copper cathode and copper anode, they are replaced by carbon anode and carbon cathode. Okay, so you have inert electrodes now. What will be the reaction at both of these electrodes? Do you think that there will be any difference in the products which are formed? Oh my God, such pin drop silence. No responses.
Miss, can I answer what I
Yeah.
think answers?
Yep.
So now the anode will not be obviously depositing its copper ions,
Hmm.
right? So all of the copper ions in the solution, the electrolyte will deposit in the cathode,
Hmm.
and at the anode,
So you say that the reaction at the cathode remains the same. It is that copper 2 plus ions, they gain 2 electrons to form copper.
yes,
Okay. And what about at the anode?
at the anode we'll get the hydroxide ions. Oxygen gas.
Yes, very good. So basically hydroxide ions, they are, since you have the same electron, same ions which are present within the electrolyte, right? The ions, they're not changing. The electrolyte is still the same. Copper 2 plus ions from the electrolyte, they will be deposited onto the cathode. They are attracted towards the cathode. They gain 2 electrons which are incoming from the negative terminal of the battery, and they deposit onto the cathode as copper. So do you think the mass of the copper still increases? Do you think that the mass of the copper still increases? Okay, let me tell you. So up till now, do you have any questions regarding the electrolysis of with copper two electrodes, copper electrodes? Anybody? Because we will be comparing both of these. So if anyone has any questions, do ask me right now. If you look into this electrolysis, supposingly the electrolyte is still the same, that is copper 2 sulfate, right? It is aqueous copper 2 sulfate. The ions, they are still the same. There are copper 2 plus ions, there are hydrogen ions, there are hydroxide ions and sulfate ions which are present within the electrolyte. The copper 2 plus ions, now what happens, the only change which I am doing is I am using carbon electrodes. I'm not using copper anodes or copper cathodes. Okay. So basically I'm switching to inert electrodes. Okay. So what happens? The copper 2 plus ions, they are deposited onto the cathode. Why? Because they are less reactive amongst both of them, amongst the copper ions and the hydrogen ions. The less reactive one is always deposited now. So copper is deposited onto the cathode. What about the anode? Anode is not dissolving. Since they're inert anodes, right? They're inert carbon anodes. They're unreactive. They do not take part in the process of electrolysis. So what happens? Hydroxide ions has greater tendency. So it is deposited as oxygen gas onto the anode. Okay, so bubbles of oxygen gas are seen or observed at the anode. The anode is not dissolving this time, right? And this copper is again being deposited onto the copper cathode. Hence, the mass of the copper cathode, again, it increases. It does increase, okay? But there is no decrease in mass at the anode since it is not dissolving, okay? The reaction is completely different now. You have oxygen gas which is being deposited onto the anode. So the mass of the anode does not decrease. What about the color of the solution, the color of the electrolyte? The copper ions, they are deposited onto the cathode to produce copper. Obviously, the concentration of the copper ions within the electrolyte decreases. Whenever the concentration of the copper 2 plus ions decreases within the electrolyte, obviously this blue color is going to fade away, or it turns colorless, or you can say that it gets paler blue. Okay, is this point clear so far? If anyone has any questions, please write your questions in the chat box. Let's move on to the next one. Okay, we have looked into the ionic half equations and all. So this process of electrolysis is a very good example of redox. And redox is basically oxidation and reduction which takes place simultaneously. If you look here in this case scenario, or in the previous reactions that we looked into, at the cathode there is always gain of electrons. The electrons, they're gained as they're incoming from the negative terminal. So these electrons which are coming in, and they're attracted, the copper ions which are attracted, they gain that 2 electrons to produce the copper metal, right? So we say that reduction takes place at the cathode, which is gain of electrons, rig. You remember it from rig. Reduction is gain of electrons. And at the anode, since there is giving away of electrons, so it is oxidation. Oxidation is loss of electrons. So we remember it from oil rig, the mnemonic. and you say that this process of electrolysis is a good example of oxidation and reduction, or its redox, where you see oxidation taking place at the anode and reduction taking place at the cathode. Okay, moving on. Okay, yes. So, looking at into the applications of electrolysis, electroplating is one of the applications of electrolysis. Electroplating basically means you're using the process of electrolysis to apply a certain coat of metal onto another metal. Okay, and this is done to either protect that metal, okay, from corrosion, or for overall appearance purposes, you can say. So the cathode is always made the object which has to be electroplated. Supposingly, I want to electroplate an object, and this object is placed at the cathode. Supposingly, I have a spoon and I want to electroplate this with a silver metal or any other metal. So this metal will be, let me just draw it. The metal which has to be electroplated is always, or the object which has to be electroplated is always on the negative terminal of the battery, or you can say that it is always the cathode. And the one which the metal which has to be deposited onto this object, or from which it is to be electroplated, this metal is to be placed at the anode. Okay, why? Because this anode, the silver, supposingly I say that silver ions, there's this silver ions, they will be deposited. First, they will lose their electrons to produce silver ions, and then these silver ions, they will be deposited onto the cathode. Okay, is this clear so far? So the cathode is always the object which is to be electroplated, and the anode is made from that pure metal which will be plated onto the object. And the electrolyte also is going to be the same metal solution of this metal which is placed onto the anode. Supposing if silver is placed onto the anode, then this electrolyte has to be some electrolyte of silver. So for instance, it could be AgNO3, which is silver nitrate. Okay, is this point clear? Yes, are we clear so far?
Yes, miss.
Okay, can the oxygen react with the carbon anodes? It can react with the carbon anodes, but there is higher temperatures are required for carbon anodes to react with oxygen. For instance, if you look into the extraction of extraction of aluminum is basically done as an industrial process from its ore, that is aluminum oxide, bauxite ore. And in that process, there are higher temperatures which are carried out. Okay, since it is also an industrial process, and aluminum oxide is itself has greater melting point. So when oxygen is produced in that case scenario, at the carbon anodes, then oxygen reacts with the carbon anodes, and those carbon anodes have to be replaced periodically since they are weared off. Okay, Zoya.
Yes.
Okay, now look into this one here. Now you see that there are two different tips of metals. There is tin, which is placed onto the positive terminal of the battery, which means this is your anode. Okay, this is the metal which has to be which is going to be electroplated onto another metal. And this metal, which is iron, the strip of iron is placed onto the negative terminal, which means that this is your cathode. Okay, so always remember, cathode has to be the object cathode always has to be the object which has to be electroplated. So this tin will be is going to produce, and the tin chloride which is present within the electrolyte, these tin ions will be deposited onto the iron metal, and hence this is how the electroplating takes place. Okay. So these are the reasons why electroplating is done. It is used to make the metals more resistant to corrosion or damage. For instance, nickel and chromium plating is done. Galvanizing, which we will look into metals chapter more depth in depth. Okay, so galvanizing is basically where we coat a particular iron or steel with zinc. Okay, and that is the reason because zinc is more reactive, so zinc gets corroded away instead of iron or steel. And also electroplating is also done to improve the appearance of the metals. For instance, we coat any cutleries with silver or gold, or any jewelries with which are coated with silver or gold for their appearance purposes. Okay. Lastly, we're going to look into the hydrogen fuel cells. A fuel is basically a substance which is going to release energy whenever it is burnt. Okay. Whenever that substance is burned, it is going to release energy. This is referred to as fuel. So hydrogen is basically used as a fuel in rocket engines, and it is also used in fuel cells to power some cars. Fuel cell is another method of driving or producing greater amounts of energy, and also generating lots and lots of energy by producing only one byproduct, which is completely harmless. Since we know that whenever fuels they are burned, they do produce energy, but they also produce, for instance, if you use hydrocarbons or any other organic compounds, or sulfur compounds, sulfur containing compounds. So any substance which is when it is burnt, it is releasing energy. However, it is also producing some byproducts. Like for instance, hydrocarbons, when they react with the oxygen, they undergo the process of combustion, they produce carbon dioxide and water, right? Or if it is a limited supply of oxygen, so it's incomplete combustion, they produce carbon monoxide and water. So both of these, carbon monoxide and carbon dioxide, they're not good for the environment. Okay, they degrade the environment. So this is one method where hydrogen and oxygen in a hydrogen fuel cell, they produce water, and this is the only byproduct. So this is very safe, and lots and lots, it also produces lots and lots of energy which can be used. Okay. So this hydrogen fuel cell produces energy by and electricity by combining both of these elements. The reactions which take place at the cathodes and at the anodes is hydrogen produces hydrogen ions, and oxygen it produces its oxide ions. Both of them, they react, they produce water as a result. So if you look into this diagram here, the air is basically blown into one side, and the fuel comes in from another side. Okay, the fuel enters, which is the hydrogen, and the only chemical product which air comes in from this inlet, and this produces oxide ions. These oxide ions and the hydrogen ions, they then react together to produce water as a result. Okay. Not much is usually asked from this hydrogen oxygen fuel cell. Other than this, you should know the advantages and the disadvantages of the hydrogen oxygen fuel cell. We know that hydrogen, which is produced from water, so this is obviously a very this is a renewable thing, and the energy which is also released, it is greater amount of energy which is released as compared to any other hydrocarbon or petrol or diesel. And this does not even create noise pollution and everything, and no other byproducts or pollutants they are found, any primary pollutants or secondary pollutants, you can say. And however, there are certain disadvantages of this hydrogen oxygen fuel cell, and that is that the materials which you use, they are very expensive, and to conduct this whole process, obviously you also require larger amounts of energy. So and these fuel cells, they are affected by lower temperatures. So which makes them less efficient in only lower temperatures. Also, the hydrogen which is used here in this, it's very difficult to store, as it is very flammable, right? So it also easily explodes when it is stored under greater pressures. So it is necessary that you should have good equipments or for storing this hydrogen. All right. So these are certain advantages and disadvantages of hydrogen oxygen fuel cell. This is it from this whole topic, and I will share some questions with you in the group. For tomorrow's quiz, you will have electrolysis, and other than that, you will have moles and stoichiometry. Okay. Any questions from today's session?
No.
And Zoya, Ayla, Basit, Ahmed, Ibrahim, Ryan, Hamdan.
No, miss.
No.
All right, okay. If anybody has any questions, do message me. Okay. Take care. Allah Hafiz. Thank you. Bye bye.
Love
Allah
is.
Hafiz.
Allah Hafiz. Allah Hafiz.